Hello ladies and gentlemen, welcome back to C.A.R. Entertainment. I'm your host Dylan Hamilton, guys, and yes, we're going to be moving over A21 Digital Technology Revision today, guys. We're going to be doing our third video, and it's going to be about data modeling, guys, and it's basically a wee bit tricky to explain because you say, oh, how do you model data and what is data modeling and all that there. We'll get into it, don't worry, it's not as complicated as you may think, but let's get into the video. So, data modeling is essentially someone you was using databases is what we're learning through the majority of it, but what it is, it's essentially showing how the data is situated and how it's presented within a database. So data modeling is used when designing a relational database. So an entity relationship or an E.R. diagram will be produced. We're just going to refer to an E.R. diagram. So this E.R. diagram basically shows where all the data comes from, where it flows to and all that there, but don't get it mixed up with a data flow diagram. That is different. As an E.R. diagram, we'll use terms such as an entity, an attribute, and a relationship, and we'll get through to this later on, and you'll probably recognize it, in fact, whenever we actually show you one. So the first step is to identify and state what data is to be stored. If you don't know what data needs to be stored, you don't have a starting point. You then need to find out what your data requirements are, the conceptual data model that is going to be produced, and how the data elements are going to be grouped. It's a wee bit iffy that there, but we'll get into it now and talk about what it means. So the conceptual data model, to start off with. The conceptual data models, there's a couple of them, identify the highest level relationship between different entities. So basically it's more or less third normal form, which we'll get into whenever we do our normalization video. So the features then of a conceptual data model is that it includes important entities and the relationships among them. So it shows all the main entities and all the relationships between them. There's no attribute specified and there's no primary key specified. So at this point you're essentially a zero normal form or first normal form. This will all make more sense whenever we go through and we start talking about normalization in the normalization video. But then you have another model which is called a logical data model, and these are different to conceptual data model. As a logical data model has entities and relationships identified, and it has keys identified as well. The attributes of each entity will be identified. So an entity may be something like product, and then an attribute of that there is product ID, for example. And this logical data model will not describe the physical structure, but it will just give these attributes and entities, and then which one's a primary key, which one's a foreign key, etc. So it will describe data in as much detail as possible without a regard to how it's physically implemented in the database. This is then whenever we talk about the physical data model, will come back, and that's how you actually talk about how it's physically implemented. But the features of a logical data model is that it includes all the entities and relationships among the entities. All the database for each entity are specified, so all the entities in the database are specified. The primary keys for each entity are specified, and the foreign keys will be specified also. Normalization will start at this level, so this is first normal form essentially. There's differences there between the logical and conceptual model. One, the logical model has primary keys where the conceptual doesn't. The logical model will specify all the attributes of an entity, whereas there's none specified in the conceptual model. And finally, the relationships between the entities is specified using the primary and foreign keys in the logical data model, whereas in the conceptual data model, the relationships are just simply stated. They're saying this is linked. So it doesn't specify and doesn't, so it's not specified and it does not specify which attributes you use for this relationship in the conceptual model. So then you have this physical data model, which actually is derived from the logical data model, and this basically includes the specification of all the tables and columns. So the table specification will include the table name and the column name. So this essentially just means exactly everything. This is every single thing. Whenever you've built your database, this is what it's essentially going to be. You'll have a physical data model. It will contain the primary key of each table, and it will specify the relationship between tables using foreign keys. So in the logical model, you'll have the foreign keys there, but it won't state the relationship between them using these foreign keys, as the physical implementation will differ based on the actual database management system used. It will represent how a model is built in a database, showing all the table structures, column names, column data types, so you're getting the data types in there, the column constraints such as validation rules, primary and foreign keys, and then the relationship between the tables. The differences between the physical and the logical model is that these entity names are now table names, so they're no longer known as an entity, it's now a table. The attributes are now column names, so these attributes are now your columns, your data, and then your data type for each column is also specified. Your data types will be different depending on the actual database being used, whether it's going to be relational or flat file. But it's probably, at this point, going to be a relational database because obviously relationships are specified. So whenever you're making an E.R. diagram, we're going to go back in the E.R. diagram. These are symbols that you're going to use. You have an entity, which looks like that there. It's a rectangle. You then have a relationship, which is this little box, which is represented by a diamond. And then you have an attribute, which is the circle. So when drawing an ER diagram, you'll create a box for each entity using that symbol or diagram. You will then draw lines connecting all these related entities. Okay, you will then label the relationships using verbs such as employee, and you will use crow's foot notation to illustrate the cardinality of relationships. Now this is essentially just drawing one line from the other, and then if you have no little spokes coming out, then that's a one-to-one relationship. If you have a one side, let's say you go from employee to member, then and at the member, whenever the arrow's at the member entity, then you have little spokes coming out left and right, just 1 and 2, coming out one above, one below. You'll know what I mean whenever you've actually done one, you've drawn one out. This is meaning that you have a one-to-many, meaning one employee can take on many members, or one staff can teach many members. But if it's the other way around, then it's obviously going to be one member can be taught by many staff, which obviously wouldn't make as much sense. It'd be better the other way around. It's very unlikely you'll be asked to do a many-to-many relationship. You'll be asked to take that out. You can also identify the attributes within the entity. So, for example, you have your entity drawn and then an arrow up to the attribute, some of what you'll draw, and then you'll label and then you'll label the attribute, whether it's ID or whatever it is. But anyway, thank you for watching this video. I've been Dylan Hamilton from C.A.R Entertainment, and I'll see you next time.